YouTube channel. So today I am discussing about a project. So it is regarding text classification. In this video I am discussing about end-to-end solution using TensorFlow. So it's a very good project, friends. So you can learn more. This is a very complex code, so it will take time to run so that's why I run before the video only. You can see my RAM and those GPU status. See, they almost occupied. So in the video it will take more time, right? That's why I did before only. So let's start, guys. So first we have to install dependencies. What and all are we required for this code? Then after installing we have to load or import all the dependencies. So TensorFlow hub and NLTK, all those libraries. And here I'm using GPU, that's why I use this NVIDIA command to know what type of GPU we have. It will tell the GPU name and all those things, memory and all those details. See, I'm using Tesla GPU. It will tell all those details, friends. So you guys can check if the GPU is available or there using tf.test is a GPU available command. If it is there, it will say yes. Or you can, this is a old command, friends. For your reference, I'm putting old command also. That the new command is tf.config.list_physical devices. So I am using CPU. We are using CPU and GPU, right? So whenever the RAM is occupied, then it will go to GPU for faster operation, right? That's why these physical devices, what device we are using. Suppose if you guys are using multiple GPUs, it will show all the multiple GPUs. So we are using one GPU, right? So the indexing will start with the 0. This is, please remember this, guys. This is very important. If you guys are working on multiple GPUs for one project, so it will start with the 0. Don't confuse. It will start with 1. Like CPU also start with 0. So if you want, that's why you want to know what is the GPU device name. That's why using this device underscore name. Using this command, you can know what is the GPU name. So it will show GPU 0. So then here I'm loading the data set, and this is the info. We have how many columns? We have only 2 columns, that is review and sentiment. And it is around 782 KB, friends. So here what I'm doing, I am encoding the labels, only 1 and 0. So without using any encoder from the sklearn, directly I'm writing a code. I wrote the code like 1 if sentiment is positive, else 0. So that is, friends. So for all the values of sentiments, so this is the data set look likes. And I am taking 2 variables, sentiments and reviews, and I'm copying all those reviews data into reviews variable and sentiments data to sentiment variables. These are numpy arrays, friends. Okay, so why I did this, we have to do train, test and validation, right? For that operation, without using any train underscore test underscore split method from the sklearn, I'm directly doing because those are numpy arrays, right? We can do slicing of the arrays with the help of that method. I am doing. So here I'm separating a train data set, validation data set and test data set. It has more data, friends. It is more data. So here for training I'm taking 31,500 rows. For validation I'm taking from 31,500 to 35,000, friends, in this between. Remaining all are I'm taking as a test data. So the data, if you see, guys, the data consists of, it is a very raw text. It has HTML tags, iframe, all those tags. So we have to clean this data, right? For that I wrote some functions for removing HTML tags. In the HTML tags we have iframe script tags, right? So for that, using beautiful soap, I am parsing it, and after that after removing those I am extracting. Okay, and I'm only after removing this get underscore text method will only take the text only. It will remove all the unwanted data. So that is the method, that get underscore text. So only text will come. After this text, this will remove if there are any new lines or the tabs or anything, it will remove, friends, this regex. So in this function, how this function, see, I wrote the comments also. This function takes a string input, so it will pass the HTML tags, then removes all the instructions of iframe. I told you, right? Iframe and script tags will be removed. Then it will take the text only. See, I told. Then replaces any instead of one or more line breaks with a single new line character. So it will replaces, friends, this regex. So then I am converting the text using standard data to UTF-8 encoding. So I am normalizing. To normalize the text, we have to use this library Unicode data, and I am normalizing and I am encoding to ASCII characters. If the data is in remaining so we will follow ASCII characters, right? If the data is not like that, so I am encoding all the data into ASCII. Then I am decoding, because ASCII code, the CPU, the machine will understand, but humans, we can't understand, right? For our purpose, we have to do UTF-8 encoding. So for that, I am decoding again. So about this function, I wrote the comments, friends. So it tells ASCII, this method encodes the text using ASCII encoding. So it will encode the text into ASCII encode, then it will decode the text into UTF-8, friends. That is all about this function. So this is about the text processing, you can guys call. Then after that, we have to apply these functions to our text, right? That's why I'm calling as a text wrangling. So I'm applying all those methods, like HTML for the tag data, I'm applying this function. Then I'm translating if there is any tabs or new lines, I'm replacing with the space, friends. Then I'm converting the text to lower. Then I'm applying this function to convert into UTF-8 encoding. Then I am removing if there are any special characters are there other than white spaces are any there. Then if there are any spaces, I am removing extra spaces after the sentences. So I am using strip method. Using strip method, we can eliminate the spaces after the lines. So then I am returning the text. So we have to divide the data, friends. Like we can, after pre-processing, we have to divide the data, right? So before also we divide the data, but we didn't pre-process the data, right? So here in this step I am doing pre-processing. So those are numpy already. Those are numpy arrays. For the safety purpose, I am taking again an numpy array and I am processing the train data, validation data, and test data. So you can see this is the output, friends. So now I am separating. I am taking. We have already train data, test data, and validation data, right? So again we have to take train function. So this is I have implemented using TensorFlow 1, friends, this entire project. So that's why if there are any issues you are facing, suppose if you install TensorFlow, if you run command like this, import tensor, it will import the latest version. The collab will import the latest version. So for that purpose, if you use this command tf.compare.v1. So it will work, friends. So all those are numpy arrays, right? That's why I took numpy input function method. If you are using pandas data frame or any data frame function, pandas function, you can put pandas underscore input function, friends. So it will work. So same. So I am training whole data set, friends, and I am predicting whole data set. That's why using the function will not change, the method will not change, only the data will change. Here I am taking train reviews, entire data, and I am predicting entire data. So here I am considering batch size 256 and number of epochs. Here I am not defining, later I will define, friends. I will show you how I defined. So then I am validating the data. This is the validation input function and train input for prediction purpose, and this is predict text function. So here I am using universal sentence encoder, friends. So this universal sentence encoder is a very good model. It trained on very large data. So the advantage of model is it is a unsupervised learning model. It is not a supervised learning model. All the transformer models used in NLP, most of them are like BERT, Albert, Digital BERT. These are supervised learning models. But universal sentence encoder is a non-supervised, unsupervised learning model. They didn't label any data by using textbooks, all the data available. So they trained. So that's why from the hub we have to import this model. So that's why I imported, I have installed TensorFlow hub. So I'm taking up.text underscore embedding column, this method. So we can define what and all our methods there. So sentence encoder, right? For that we have to define sentence and model spec. So this is the link of that model. So here I'm not putting training like true in the ifs only. After I will define based upon our requirement, our output, we have to define, we have to fine tune, right? So this is called fine tuning. So I'm taking df.text method. So we are doing classification, right? That's why I'm taking this method. How many hidden units, how many hidden layers you want. So under feature column, this model, right? This model, using this model. And how many we have, only passed one negative, right? So we have only have two output way, two output layer, we have only two neurons. And activation function I'm using ReLU, and dropout I'm for avoiding overfitting, I'm using dropout layer, and optimizer I'm using the grid with the learning rate of 0.005 friends. So you have defined the model, you have load the model, you have defined the, you have fine tuned the model also. Now before I didn't use epochs, right? Now I am finding the epochs. So 256, this is the batch size, friends, and we have this much data. And so the 1200 means the step size, the total steps, in how many steps you want to do. So this will give epochs, friends. So total it gave 9.75, so we can round figure to 10, so we can use 10 epochs. So we are evaluating model. So this is, so total steps we have 1200, I mentioned you, right? Step size is 300. So we have to run a for loop, right, to train the model for all these steps. So that's why I took the for loop, and so I am printing the step size is 300, right? So it means 0 to 300, after 300 to 600 it will go like, that's why I'm printing every training step using this command, using this code. Okay, then I'm training dnn is the our variable where we load the model. So that's why using dnn.train we are training, this is the training data steps, how many steps. So based on, we have already defined the step size, right? That's why I gave step size variable. So it will give the time, I have mentioned how much time it will take. So see, it will start like the training for step. Initially it will take 0 to 300, that is the step size, right? So don't worry, friends, this is not a error. I already run the error before, but I put the wrong spelling, that's why. So already model trained, right? This is a evaluation step, anyway we can print later, that's why already model trained. So don't worry, that's why my all the remaining code run. So after evaluating using predict train input function, so this is a training evaluation, friends. So we got 74 accuracy, and the precision is 76%, recall is 70%. Okay, and this is the text accuracy, test results accuracy, we got 74. And see friends, using dropout there is no difference between training accuracy and testing accuracy. So we can say if we use large models also, we didn't find overfitting because there is no bias, there is no variance. The difference between training accuracy and testing accuracy is almost null. So model is not overfitted, but don't think the accuracy is less. It is a very good accuracy, friends, don't confuse. See, here we don't have faced any overfitting issue because we implemented, I have trained like that, right? So that's why. So in this step what I'm doing, building a generic model trainer on any input sentence encoder. So if you take any inputs and any sentence encoder, we can apply, we can train this using function. So I define that function. So already embedding feature is we have to load the universal sentence encoder, right? So I'm using this already. I have defined from the hub we have to take, right? That's why we have to take a sentence and the model hub model trainable. So we have to train underscore module. We have to define these parameters, friends. So the code will be same. Before we define the right, how many hidden layers, what is the model, same code will repeat it. But I'm putting in some function to train with any data. So same friends. Here also we have to run a loop to calculate the metrics. We have to evaluate. So after that I'm printing using, you can say, a dictionary format. So what is the training accuracy, test accuracy? After all, I am defining this is a function, right? So I have run that. That's why we are not getting any output. But after that we can predict using this function. So estimator is a DNN, our estimator, right? DNN is our estimator, that is the variable. Predict, we can give what function we have to use. Okay, so here estimator is DNN input function for what you want to predict. Using test data we need predictions, right? So using this I am only taking only 10 predictions because the data is more, right? I want only 10, so it printed 10 friends. Now let's go into the confusion matrix. It will tell clearly. So this is the command for confusion matrix. What and all are you want to give? Sentiment, test sentiments and predictions. This is the true data. This is the predicted data, friends. So I am labeling, and this is predict. X axis is the predicted, y axis is the actuals. See total 5. See friends, if you see, I can print a classification report from using sklearn. Based upon that you guys can understand. Okay, so how many are negative? See, this is the negative friends, this is the positive negative. Okay, see, actual, and this is the predicted, friends. Okay, so this is all about the confusion matrix. So this is all about the code, friends. This is all about the text classification. I hope you guys enjoyed this video. Please subscribe my channel. Thank you all. Thank you so much.